Hello, I'm going to do a walkthrough of the questions or the types of questions you're going to get for the Chapter 4 Quiz 2. So the first one, what is the to-tell area for the following question? So for this question it says a 94% confidence interval for the mean daily average temperature in Albany, New York is 70.56 and 73.04. This is based on a simple random sample of 15 observations. So to find the to-tell area, you're going to need to find the following values. The degrees of freedom, which is n minus 1, which in this case you've got 15 observations, so 15 minus 1 is 14, and your confidence interval, where your confidence interval is 94%, which is equal to 0.94, and that's going to be your middle value. You then take that and put it into the probability calculator. So here's our probability calculator, and we need it to, oops, sorry. Okay, so it's a student T, degrees of freedom is 14, the middle value is 0.94, sorry, there's 0.94. We click calculate, and we're looking for the, I think it said the middle value, two-tailed area, which is this one right there, 0.06. So that would be your answer for that one. So answer 0.06. All right, for the next one, how many degrees of freedom? Well, we already did it. It's kind of a silly one to include, but we do. So for degrees of freedom, it's just n minus 1. In this case, there are 7 observations, so 7 minus 1 is 6. So that's our degrees of freedom. All right, estimate the mean, the sample mean. Remember, the sample mean is also known as the observed. So for this one, we're going to use the formula for the confidence interval limits, which is the upper and the lower, to find the sample mean. All right, so lower limit, remember, is observed minus the critical value times the standard error, while the upper limit is the observed plus the confidence value, critical value, I'm sorry, times the standard error. The lower limit is this value right here. So we have the 94% confidence interval for the mean daily low temperature is the 1.34 and 9.88. 1.32 is your lower limit, 9.88 is the upper limit. So that's where I have lower limit, the 1.32, upper 9.88. You then take those and put those into your formula. So that's the lower formula, the upper formula. So 1.32 is equal to the observed minus critical value times SE. Same thing for the upper, except we put the 9.88. Then what we're going to do is do a little algebra. So I hope none of you freak out, but we're doing a little algebra. So we're going to actually add these two equations together because they've got the same unknown. So we've got 2 observed and the 2 standard errors, but they're all the same. So that way we can actually combine these 2 formulas by adding them together. Well, since this is a negative and a positive of the same thing, they cancel each other out, so we can ignore them. We've got 2 observed, so the 2 equal 2 observed, and then we just add 1.32 and 9.88. So we get 11.2 is equal to 2 observed. We then divide by the 2 to get rid of the 2. So 11.2 divided by 2 is 5.6 observed, is the observed value, or it also could be called the sample mean. So that's how you work through the estimate the sample mean. All right, estimate the standard error of the mean. So for this one, the first thing we need to do is find the critical value. So we what we were doing before on the probability calculator is similar to this, but what we're going to do is find the degrees of freedom. So in this case, we've got 21 observations, so 21 minus 1 is 20. The confidence interval, which is 96, we use the 0.96, then we use the probability calculator right here, and we do, this is going to be our 20, this is going to be our 0.96. We click calculate and we get the 2.196658, which, there it is right there, the 2.196658. All right, the next thing we're going to do is find the sample mean or the observed value, which, remember how we did that? So when I say that, I'm just kind of going back to the same process that we did right here. We're just now going to do it with these values. So in this case, it's 1.72 is the lower limit, 9.48 is the upper limit. It's going to be equal to the observed minus CV times SE, and this one's going to be plus. Well, because this is a minus and plus, they cancel each other out. We just end up, and I know these are both 11.2. Well, sue me, I was trying to be easy for myself, but it won't always be 5.6 for the observed. But go ahead, add those two, get 11.2, then divide by 2 to cancel out that to get your 5.6 is equal to your observed. And then what you're going to do is actually plug in that the critical value. So remember this critical value that you found in step 1 and the observed value that you found in step 2 into the lower or the upper limit formula to solve for SE. So it doesn't matter which one of the two, the upper or the lower that you use, you're still going to get the same standard error. For me, I just went ahead and used the lower. So you put the 1.72 is equal to 5.6 minus the 2.196658 times the standard error. Well, order of operations, so once again we're doing algebra here, you have to get rid of this part first, the 5.6, because we're working backwards. You can't work with the multiplication part until you've got rid of the addition part. So that cancels that out by adding the 5.6 over here. 1.72 minus 5.6 is negative 3.88. which then leaves us equal to the negative 2.196658 times the standard error. Now you can divide by the 2.196658 to get, and you do the division on both sides, the 1.766319564 is equal to your standard error. So doing the algebra here and over here for the sample mean is going to be really important. So if you're having problems with algebra, please let me know. But that's all we're doing here is just some simple algebra. All right, so we've got the standard error. We're then going to estimate the standard deviation. When you do these for the actual quiz, you're going to get a whole problem like that, and you're going to have to work through all of these steps and then do this. Well, for me, I'm just going to skip to estimate the standard deviation of the temperatures, use the data from above. So we're just using this data. So remember the standard error, which is what we just found, is equal to our standard deviation over the square root of n. Which is our number of observations. We know that number is 21, so we can do the 1.766319564, which is what we found from the problem above, is equal to the standard deviation divided by the square root of 21, which we've got right there. Now if you do the algebra for this, which means you've got to multiply both sides by the square root of 21, so cancel that out and then multiply it over here, and you end up with 8.094293104 is equal to the standard deviation. So once again, when you actually do this for the quiz, it's not going to be quite this simple because you're going to have to go through all of these steps. So you're going to have to go through step 1, 2, 3, and then this will be step 4 for estimating the standard deviation. So I just went ahead and skipped around so I wouldn't have to go through all of that for this video. But when you do it for the quiz, this will be right here is step 4. So just kind of come back up here and do 1, 2, 3, and then 4. All right. So estimating the margin of error, this is something else to where this could also kind of be a step 4. So we're going to estimate the margin of error using the information from the standard error question. So we're going back up here to the standard error question. And we're going to use that data, which mostly we're just using the standard error right there for that question. When you actually do the margin of error, you're going to have to do step 1, 2, 3, and then come down, and this will be step 4 for margin of error. I just went ahead and skipped to it to where margin of error is equal to the critical value times the standard error. So the margin of error is equal to critical value standard error. So ME is equal to 2.196658, which was our critical value that we got in step 1. And then the standard error was step 3. So to do this one, we needed step 1 for the critical value and step 3 for the standard error, which then allowed us to get step 4, which is this ME, where we just multiplied the 2.196658 times the 1.766319564 to get 3.88000001. Whew. Okay, you still with me, everybody? All right, moving on to estimating the critical value. Now this one's a little bit different. We're going to start by finding the sample mean. So the first thing you do when you're solving for the critical value or estimating the critical value is find the sample mean. So we've already done that before. We're going to use the upper and lower limit formula again. So we've got our 2.14 from up here, our 13.34 from up there, put them in, equal to observed minus our critical value times, and in this case, they actually gave you the standard error, which is really nice. You didn't have to find it. So we've got our standard error there. So by doing our algebra, we ended up back up with 5.6 observed. I do promise, I'm sorry, I didn't realize it was going to be quite this bad, but when you're actually doing these for the quiz, the observed is not going to always be 5.6. That was, once again, just for make it a little bit easier for me. Once you get the 5.6 for your observed, so as soon as you get your observed value, you're going to plug your observed value back into either the lower or the upper limit formula to solve for the critical value. So this is really similar to when you were solving for the standard error. Normally the standard error, this was the standard error and you had the critical value. Well, this time you don't have the critical value, but you have the standard error. So I used the lower limit formula. So I use the lower limit formula of the negative 2.14 equals the observed, which we now know is 5.6, minus the critical value times the 2.4422, which is the simple random, or the standard error of the mean, which we got from the formula right there. So when you do the algebra out, so we're going to subtract 5.6 from both sides. That gives us negative 7.74 here, which is equal to a negative critical value times 2.4422. So to get rid of this negative, because we don't want a negative critical value, we're just going to go ahead and subtract by negative 2. Or not subtract, divide by negative 2.4422 on both sides. By doing that, we cancel our negatives out, and we get the 3.169273606 for our critical value. Yay! Okay, so now we're going to estimate the size of the sample from the critical value question. So in this case, if you're thinking, oh, this shouldn't be too bad because we're just going straight to here, well, in most cases, you're not going to get a critical value. You're going to have to solve for the critical value. So you're going to have to go through steps 1 and 2, and then this will be step 3. So we have, well, 3 is get the critical value. So technically, you'll do 1, 2, and step 2 here is technically step 3 if you're actually doing this for the quiz. So you need to get your critical value, which is we did in the last problem. Then we need to go to the online probability calculator and use the 99% confidence interval. And that's from right up here, the 99% confidence interval. All right. And then we're going to try different degrees of freedom to try and figure out which degrees of freedom would get you closest to the confidence value, or the critical value, I'm sorry. So basically, we're going to have to play around with different degrees of freedom to try to figure out which degree of freedom would get you closest to the critical value. So we've got this critical value, and we're trying to figure out which degree of freedom would get us closest to this critical value. I will say in most cases, you will not be able to find a critical value that matches exactly what you have, so you just need to find the one that's closest. So what I suggest doing, just throw out a degree of freedom. So in this case, I tried 20 with a middle of 99. So right here, I tried 20 and a middle of 0.99. Click to calculate, and that's 2.85, and so we're looking for 3.16, 2.84. We're not even close. So then, see over here, I tried the degrees of 25. So come back up. Let's change this to 25. Come back over here. The middle is still 0.99. Click calculate, and we've got negative, or 2.78. So we don't use the negative, use the positive. So here you can see what I'm doing. I just went through degrees of freedom 20, the middle is always 99. When I do that, you get a critical value of 2.8. So that wasn't correct. So I said, let's just jump up 5 and see what happens. So I did degrees of freedom 25, middle 0.99. Critical value, this case, was 2.78. Well, the thing we're trying to get is 3.16. Well, we went down. So it looks like going up in degrees of freedom isn't working. So instead, I'm like, let's try going down instead. So up actually made this go lower. So then let's go down, and when I went down, so this time I try 15 and 0.99, and whoop, yay, we went up. So this time we went up, which is what we want to do. So I'm just going to go ahead and keep trying, because remember, we're trying to get as close as we can. So I'm going to try 10.99, calculate, and 3.16, and woohoo! That actually is the value. Well, in I think pretty much every case, you aren't going to get the exact right value when you do this. So what you're going to want to do to double check that is try the value below and above it. So we like 10. Well, what would happen if we went down to 9? And calculate. Does it get us closer or further away? And in this case, it went, if we do degrees of freedom 9, it goes a little bit up to 3.24, which is not what we want. So what would happen if we did 11? So you can see we're just kind of playing around with these values until we get one. That's 3.10, 3.10, that's not what we want. Okay, so we found a value we think we like, we tried the value beneath it, we tried the value above it, and then what you do is just pick the one that's closest. So in this case, it's the 3.169, which really is the critical value. Like I said, in most cases, you're not going to get an exact one, so that's why you need to kind of go back and forth. So once you get really close, you're going to need to go up one, down one, up one, down one, and kind of write these out until you get the one closest. So we know our degrees of freedom is 10. That's the one that gets us the closest critical value to what our critical value was, but be very careful. We do not want the degrees of freedom. We want sample size. So once you get that sample size, or once you get the degrees of freedom, put it back into the equation, which just means basically add 1, and that 11 is the actual answer. So don't get the degrees of freedom confused with your n. We don't want degrees of freedom, even though you need to find the degrees of freedom. You then use that degrees of freedom to actually solve for n. So n is the answer. This is the answer. But that concludes all of our questions. If you need anything, let me know, and I hope this was helpful.